Hello, my name is Efrat. I'm CTO and co-founder of MUs. And I'm going to talk today about how we use social buzz for an engaging AI experience. So a little bit about myself before we start. As I said, my name is Efrat Blaier. I have 12 years of experience with machine learning and NLP and textual analysis. I have a computer science degree. I'm an Atudait and also a business management degree. And after a few years in the industry and in the army, I decided to join a startup and started 3 years ago. So we're in the area of conversational commerce, being able to talk to someone in free text and do commerce. Just like you come into a store and you talk to a person and he sells something to you in an offline store, we do it online. So this field of market of using automated agents is going to reach $5 billion by 2020, and it's very, very expanding. And we, inside that market, provide a way to automatically turn big catalogs into a smart shopping assistants. So a way to come to a store, they don't do anything. The agent automatically learns the catalog and knows how to interact with people in order to sell something for them in free language. So just to explain a bit about the two things that make up this technology, the first is understanding a domain, knowing how to understand everything for a specific market. Let's say for fashion, knowing that there's different kinds of types, dresses, different kinds of features, brands, everything inside that domain. We use unsupervised machine learning to do that. I'm not going to talk about that in this talk, but I just want you to demonstrate it because otherwise you won't understand the next thing that we do. The next thing is having an artificial intelligence that uses this understanding and just has a light conversation with the user to drive the user towards a sale. So inside that, we'll discuss how social buzz comes and plays into action. Let's see a short demo for the understanding of the domain knowledge. So classic PowerPoint. So here we go, and we see it through a chatbot. The chatbot allows us to interact online with free text. So a user may come in and say, I need black jeans for my wife. We can understand that black is a color, jeans is a product type, connect it to a specific product catalog, and start a conversation with the user. Then the user may say something else, like, she doesn't wear skinny because I know she's not into that. So we understand that skinny is a type of fit and it's in a negative form, and we connect that to the catalog once again. On top of that, the user can say different things like specific features of the product, saying something like, I want it to be cheaper. So it's not a specific feature, but a relative thing. Knowing how to understand everything in this fashion world is the first thing that we're doing. And it's machine learning to understand the domain. The second thing is having a conversation that's also guided by the AI and not only by the user. So for example, if someone comes in and says, I'm looking for a black mini dress, the AI at this point will try to ask the right question to make the user buy something. And the right question in this case is simply asking, oh, last week Jessica Alba was seen in this kind of dress. It's black mini, but it's also lace and has long sleeves. Maybe you'd like that. And if I'm a user that's like 30-something woman, I might be very interested into buying that. And this will shorten my path to conversion by very, very much. So using this kind of social buzz, and on top of that, giving the conversational layer, will allow for a much richer experience that in the end will create a conversion. So the question is, how do we do that? So first of all, when someone comes in and says, I want a black mini dress, we can take into account what kind of things this user already bought, and the profile, and different things from the store, which is the classic thing everybody's doing. Or we can take into account some social buzz data. And we may ask one type, what fabric would you like? Do you want a sexy dress? What sleeve length would you like? There's like a million questions you can ask at this point to make the funnel a bit smaller. And the thing we want to ask is the most thing that will drive us to conversion. So in this case, we'll ask about the Jessica Alba kind of dress because we think it will help the user buy it. So how do we do that? We have a platform that uses Twitter Streaming API. Once we understand the domain, in this case fashion, we know how to listen in to all the tweets about it. We use those tweets, we pass them through a whole funnel of workers like filtering and entity extraction, understanding celebrity names, different types of our own entities from that. And we use a framework called Apache Spark, which you're probably familiar with, that has a machine learning library as well. And we use a streaming k-means clustering algorithm. The goal is to create clusters, which are topics of social buzz around a specific entity, like a celebrity, and has specific commerce features, like different features of a dress that might be interesting to the user to buy. It's always changing. That's why it's streaming k-means. And I'm going to show you a bit more details about how we do that. So streaming k-means Apache Spark framework takes into input only vectors. It's a numerical representation of texts. Our texts are tweets, and we want to take those vectors and create the clusters from them. So when we take a look at those specific tweets, you see different words inside the tweets. We use a bag of words approach, treating every word as something different. And then we turn that words into vectors. And the way to do that is to take every word, give it a specific column in the matrix, and have a representation for every tweet, have one for if a word appears in that or it doesn't appear. So the vectors are very, very long, they're very sparse, and there's one if the word appears in this tweet or doesn't. And the amount of tweets, as you can understand, is billions, millions that always change all over the day. So this is a bag of words approach. And what we do here is also apply TF-IDF, which is giving a term frequency for words that appear more times, but reduce its meaning if it appears in a lot of tweets. Words like the or a, which are very, very common, will have a very high document frequency, and then when we apply it, it will have very little weight. So the vectors change accordingly. So once we took that and created a vector representation out of that, we can apply now the streaming k-means. It's a third-party library from the Apache Spark. And then we create those clusters. And clusters, a graphical representation might be all the tweets around Jessica Alba's dress, or all the tweets around something else. And every single cluster is a social buzz topic that people talk about it in a positive way, and it's around something that we can sell. Otherwise, it doesn't make sense for us to monitor it. And then we use all of that and have topics with enough data, positive topics, and measure the buzz strength. So once we take all of that into account, we generate some 150 topics per day for a single vertical. A vertical is, for example, fashion, beauty, electronics, and we use that inside our conversational AI to guide the users towards conversion, and it changes every day. Today it's Jessica Alba's black dress, tomorrow it's something else. So when a user starts to show signs of not being sure of something, we show them this kind of trend, and it, in most cases, drives the user towards interest, and in the end, towards a sale. So that's what we do. It's only one piece of the puzzle. It's not everything in the AI world, but it's an important piece. But otherwise, the conversation is very, very dry, very functional, very guided by the user, and we want the conversation to be guided by the agent. Just like you walk into a store and get the right questions to make you buy something, and even if it's not something that you originally wanted. So that's what we do, and we do it in the online world. Thank you.